So we are doing number 10 on the Newton's Extra, and they're asking a question of 3 boxes are in a contact and resting on a horizontal frictionless surface. One box has a mass of m, which is 1 kilogram. You have another box has a mass of 2. Another box has a mass of 3. A horizontal force of a magnitude F is being applied. So right here is the magnitude of F being applied to the first box, which means if it's applied, we have a force applied, which is what you're going to write down. Actually, you can write down, while you're doing this, you want to write down your F net. Your F net equals your force applied. Because it's frictionless, I don't think it doesn't really matter. Force applied to the first 3 boxes across the surface because it is a frictionless surface. Because the box is only being applied to this one, they want to know, is it going to affect the other boxes? If other boxes are going to move or not? And the answer is yes, because the force is being applied. But the way to find it, you're going to add all the boxes. So because they're giving you a box of 1, another box of 2, another box of 3, if you add them all together, they give you 6 kilograms, which is the force that has to be applied to move the boxes. And you're trying to find the acceleration as it goes. It says find the force of box 2 exerted on box 1 as both boxes accelerate to the table. So what you're trying to find is what this force is in between box 1 and 2. And you're going to use this equation, F net of x, because we're trying to find equals FA, because that is you have the force that is being applied. So now you just simplify this out, and this gives you MA equals FA, right? You're trying to find the acceleration, and they're giving you the mass, which is this total goes in there for the mass. So once you're given the F net, the MA equals FA, you're just going to plug it in. You have the 6, you have an A, and equals the force, right? So now you have to find the A. You just have to do algebra, which is when you divide by 6 and you divide by 6. So you have this part. But then it said the answer that you have to get is 5 over 6F. This is the real answer. Wait. 6 over F. I forgot to explain something. We found the 6 over F because we found A. But I forgot to, when you have the 1, the 2, and the 3, 3, 2, 1. Ooh, it's really ugly. The 3, 2, 1. You have to add only these 2 together because it's like subtracted, because this is just the one being applied to, but it's just being added on to the 6. So 6 minus 5, 6 minus 5 gives me 1, right? Oh my god, what am I doing? 6 minus 1 equals 5. So I have, my acceleration equals the 6 of 5 of the force as I'm using. So I'm going to divide by 6, because I'm trying to find the acceleration again. So it gives me 5 of 6, which gives me the answer. Hold about this. It gives me the answer of 5 of 6 over F, because I had the 6A of 5 of the force, because that is what is the force when I add the 2 and the 3, which is what is trying to be pushed. You divide it by 6, you divide that by 6, and this gives you the answer. When you do it right, when I didn't do it right. But that's your answer. Bye.